everyone, I welcome you all to my new video series of Principles of Compiler Design. We all very well know about that compiler is the very important system software which does the translation process. So this compiler can be called as a translator that translates the program written in one language to a target program in another language. So the source language may be an high level language which may be written in C or C++ or Python, whatever it may be, those can be called as the high level language, and the target language can be of assembly code, where again the assembly code has to be translated through the assembler in order to generate the target machine code. So this is the basics of the compiler, and now in this video we are going to look on into the automata and with regular expression. When we see the compiler as a course, the prerequisite for this compiler to be learned is the theory of automation. So the theory of automation is entirely about the finite automata, and now we'll have a gist or the introduction to the finite automata because that forms the basics for your lexical analyzer. So here we'll get into the video of how to write an regular expression, what exactly a regular expression is, and we'll see the series of examples and with a small application or an introduction to the finite automata. Let's enter into the video. Okay, so now coming on to this regular expression, this can be called as a set of strings that are defined from an alphabet. Alphabet defines possible symbols which can form the string. So a regular expression can be called as the set of strings, and now this set of strings can form the language. So this language becomes the what we are going to provide it as to the input of the compiler. So hence this regular expression can be considered as a powerful tool in order to find the pattern matched for a given expression. So the various applications that includes for this regular expression is we can go for the data validation and text extraction and search and replace. These are all the various applications where these regular expressions find a major work and popular in the string match, pattern match and replacement. So here I have given 3 examples. Example 1 will take a combination of alphabets as A and B. So that using A and B, the set of strings formed as AB, ABB, ABBB, it goes on. So this is the possible set of strings which the user can give. Now the regular expression which will accept all these type of input string should be written as, first when you find the input string, here the input symbol A is common in all the string. So we are defining it as A is the must appearance in the pattern. Then followed by the input strings, we see that B has at least one occurrence in the input string. So that should be defined as B plus, which means that one or more occurrence. So now the pattern used for the input string in the example 1 is AB plus. So that will find the match for all the type of input strings which are all given in our example 1 for the language L. Similarly, take the example 2 and example 3 where we have written the regular expression for the given possible set of strings. This is not limited to. We are having lot of set of strings which can be formed. Yes. So now technically defining the regular expressions. This consists of any kind of non-terminals. So terminals means that cannot be expanded again. That is called as terminals, which consist of the symbols A, B, C till Z with a cap symbol. And we have certain properties for this regular expression called as the union of regular expression, concatenation of expressions, and the iterations, repeatedly occurring the iteration of regular expressions. In the first case, union of regular expressions, we are going to take the common symbols present in both the regular expressions. We are going to add it up. Then in concatenation, the first regular expression symbols will be attached with the second set of regular expression symbols. And the third one, iteration, that means 0 or more occurrence, which means that the same symbol will be repeated again and again in the given string. So these are all the three major properties of the regular expression, and below which I have given the examples that formed using the sets and what is the regular language given for those properties. Okay, so now here, whenever the input symbols are given, the symbols, for example, take the first one. Here the set of strings over 0, 1. These 0, 1 is called as the alphabet or the symbol. So based on that symbol, the regular language is defined as possibilities of ones and zeros combinations. So when we look on into the possible input strings, the pattern to be matched is taken as 0 union 1, which is taken with the iteration and followed by 3 ones. So 0 or 1 may occur 0 or more times, but the 1 1 1 pattern must be matched in all the input strings. So this gives you two properties of what we have defined in the regular expression. And these are all the some more examples which defines the set of strings over a certain rule followed by the input singles. And here we have given in a sentence format. Even the regular expression can be explained in a normal high level language. For example, take set of strings over 0, 1 which starts with 0 and ends with 1. So this is the definition of the regular expression, and formulatively it can be rewritten as 0 followed by 0 or 1 star iteration, and it must end with 1. So this is the formal regular expression given for the language descriptive expression stated by the user. So in what ways these regular expressions are going to be supportive? These regular expressions are the basics for the finite automata. When the finite automata wants to work, definitely the regular expression forms the basics, whereby we are going to test the condition. If the pattern is matched by the input string, it will go to the next state from one state. So that state to state transition is called as the finite automata, which takes from the regular expression. So here I am going to show you one of the real-time example where the finite automata takes the role. Here I have displayed the signal where it changes from red, yellow and green. So how it is going to change? It changes from one state to other state based on the input. So based on the input, that input is called as the input symbol in the regular expression. And what the pattern matches is, once if we get into red, we have to go to yellow and then to green. So this is the pattern which is to be followed. So likewise, this is the application where the finite automata is working with the regular expressions. Thank you.